In the realms of theoretical physics and computational science, a captivating idea has emerged: the notion that the universe itself fundamentally operates as an immense cosmic computer. This intriguing perspective suggests that the intricate phenomena we observe are the outcomes of underlying computational processes governed by mathematical rules. At the heart of this concept lies the profound implication that the universe is not merely described by mathematics, but is inherently mathematical in nature, where every particle, every force, and every interaction follows an intricate set of computational algorithms. One prominent theory that embodies this computational view is Stephen Wolfram's hypergraph model of the universe. Central to this framework is the concept of a hypergraph, a generalized form of a graph where nodes or vertices can be connected by edges that link more than two nodes simultaneously. This structure allows for a rich representation of complex relationships and interconnections that extend beyond simple pairwise connections. In Wolfram's theory, this hypergraph dynamically evolves according to specific computational rules, rewriting itself in a perpetual cycle that mirrors the progression of time and the evolution of the cosmos itself. Each node in the hypergraph represents a discrete element of space, while the edges symbolize the fundamental relationships and interactions between these spatial components. As the computational rules are applied, the hypergraph undergoes continuous rewriting, simulating the ever-changing fabric of space-time and the unfolding of events within the universe. One of the most profound implications of this model is its interpretation of the speed of light. Traditionally, the speed of light represents the cosmic speed limit, the maximum velocity at which information and matter can propagate through space-time, as dictated by Einstein's theory of relativity. However, in Wolfram's computational universe, this speed takes on an additional significance. It becomes a computational limit as well. This remarkable concept suggests that the speed of light not only restricts the physical propagation of information, but also imposes a fundamental boundary on the rate at which computational processes can occur and spread throughout the hypergraph of the universe. Just as information in a conventional computer travels from one component to another at a finite speed, so too does information propagate through the cosmic hypergraph at a maximum rate governed by the speed of light. This profound connection between the physical and the computational realms hints at a deep intertwining of the laws of physics and the underlying computational processes that drive the universe. The idea that the universe is fundamentally a computational entity has profound philosophical and scientific implications that challenge our conventional understanding of reality. It offers a novel framework for unifying information theory, physics, and computer science, potentially shedding light on unsolved mysteries such as the nature of quantum gravity and the reconciliation of general relativity with quantum mechanics. Moreover, if the universe truly operates as a cosmic computer, it raises thought-provoking questions about determinism, free will, and the very nature of existence itself. Are all future events predetermined by the initial conditions and computational rules that govern the hypergraph? What does this imply for our understanding of causality, choice, and the fundamental fabric of reality? As theoretical and computational tools continue to evolve, testing and refining such models will remain a formidable challenge, yet one that promises to expand the boundaries of our knowledge and comprehension of the cosmos. The exploration of the universe through the lens of computation not only deepens our grasp of the physical world, but also invites us to rethink the philosophical foundations upon which our understanding of reality rests. As we venture further into this uncharted territory, the intersection of computation and physics will undoubtedly continue to be a fertile ground for discoveries that could profoundly reshape our conception of the universe and our place within it.